In the last video, we saw how to leverage load shedding in a Spring Boot application. So we created an in-flight request filter. We configured the max request as 3, and then we were running a local Spring Boot application, and I was showing you how load shedding works. Now I'm going to show you with two different replicas. Basically, I'm going to run two instances of the application. One application is going to take longer time to respond. The other application is going to respond quickly. I'll show you how Kubernetes can leverage the load shedding and redirect traffic to only one instance, so that if we do more requests, right, it always gets redirected to a healthy instance depending on the health check and stuff like that. So I'm going to configure the greetings controller. So earlier we configured the greetings controller to respond within a minute. I think it was just sleeping for like 60 seconds, right? I'm going to increase this to, like, let's say longer, right? I'm going to increase it to, let's say, 2 minutes. So I'm just going to say, or maybe like, let's say 90, right? 90 seconds, 1.5 minutes. So I'm going to configure the application to respond after like 1.5 minutes, 90 seconds, right? I'm going to build this particular jar. Let's do a clean install. We are going to run this within Kubernetes, so I need to convert this into a Spring Boot container. So Spring Boot recently came up with this Maven Graal compiler using the Spring Boot plugin, right? So you can leverage the Spring Boot Maven plugin to build a Docker container. Also, since I'm going to use Kubernetes, I will be leveraging something called as readiness probes. So using readiness probe is what I'm going to identify if the application is up or not. So I'm going to add the actuator dependency, because using actuators we can add health check endpoints by default. So I'm going to leverage the Spring Boot starter actuator. This will add our actuator endpoint or health check endpoint, so that we can do a health check and then identify if the application is up or not. So I'll leverage that. Let me rebuild it again. So once it's rebuilt, it will create new jar version. The version of this particular app is 001 snapshot. I'm going to change this as 1.0, let's say, right, for simplicity. I'll rebuild it again. So I'm going to create load shedding example with version 1.0, because I'm going to build two versions of the application, one with the with this delay of 90 seconds, the other one without the delay, right? So we built the app, the jar is built. I'm also going to build the Docker image. So in order to do that, what we can do, we can leverage the Maven Spring Boot build image plugin, right? Using build image, it will use build packs to create a Docker image. I didn't have any custom requirement here, right? It's a simple Spring Boot application I'm building. I didn't have any custom requirement on what steps or what base images to use. So I'm just directly using the build packs base image, right? So it's going to create a new image for me, load shedding example 1.0. That's what it's going to do. So let's meanwhile while it is building, I'm going to also add a Kubernetes deployment config file. So I'm going to call this as deploy Kubernetes or deploy.yaml. Let's keep it simple. Deploy.yaml. I have already preloaded some default scripts, right? So I'm going to leverage that, but we are going to modify it. So what we have here is one deployment. I've added a one deployment, and I also added one service. So service is a load balancer in Kubernetes. So I'm going to use the load shedding example load balancer, right? And I'm going to use a deployment. So since I'm going to use two different versions of the deployment, I'll also add one more. Let me copy paste the same, right? So I'll call the application as load shedding example 1. I'll reduce the replica to 1. The labels are going to be the same, because I want to use the load balancer to load balance between these two applications or two deployments. So I'll keep the matches or the labels same. The version of this particular app is 1.0, right? So let me change this to 1.0. Also, we have configured the readiness probe, right? So readiness probe is configured, for example, actuator health. So there is an initial delay. I think I'm going to reduce this to like 2 seconds. And also, how frequently should we check this actuator, right? So I'm going to change this to, like, let's say 2 seconds again, right? So initially it's going to take 2 seconds, and again it's going to take 2 seconds to every 2 seconds to query. You can reduce it to 10 seconds, because I'm going to show you by running quickly. So I want to like show real time how it is, right? First we'll do 2 seconds, and then I'll show you 10 seconds. What's the difference between these two? I'll show you how it affects the application's health, right? I'm reducing it to 2 seconds. For the second deployment, I'm going to call this as, again, load shedding example 2. right? We'll reduce the replica to 1 again. The matches are going to be the same. Here I'm going to use the version of the application as 2.0, right? 2.0 is going to be a healthy one. So again, I'm going to use the initial delay as 2, periodic seconds as 2, right? So I think we should be good here. Yeah, so our deployments are ready, just that our images needs to be built. We already built the version 1 image. Let's see if the version 1 got built successfully. Yeah, I can see the successfully built image Docker load shedding example 1. Meanwhile, I'm going to change the code in the greetings example. I'm going to remove the sleep here, right? I'm going to remove the sleep and I'm going to clean and build again. Also, sorry, I forgot to change the POM here. So we need to have a 2.0 version. So let's build a 2.0 version. So once the jar is built, we can build the image. So that's done. Let me build the image. This should build a new image with 2.0 tag, and we can use that inside the Kubernetes deployment. Meanwhile, I'll show you what deployment I have locally. So I have Rancher running. Rancher desktop is something what I'm using here. I'll also open a terminal. Let's open a terminal. I'll maximize this. You can see there is nothing in this the Rancher desktops alone resources are there. So none of the resources are running. I don't even have any service. Right, the default one is present. That's it. So I'm going to create. Let's do. I'm going to create multiple terminals so that we can easily work upon. So I'll keep this one as is. So what I'm going to do, I have custom scripts, right? If you had seen, I had the loop.sh. I'm going to leverage the same loop.sh to loop through the greetings endpoint, right? So that way we create artificial traffic, right? Also, I'll show you how it this is going to help us, right? I'll also create one more horizontal. So I'll show you the script which is there here. Loop.sh is nothing but a curl which is doing a curl on the IP address. I'll show you what IP address we get once we deploy. Let's see if the image got built. Yeah, the image got built. So since the image is built, the images are ready. I'm going to apply this Kubernetes configuration so that we can get the pods and the services up and running. So I'll do a kubectl apply -f and then deploy.yaml. This is going to create two different deployments for us. So it says that created load shedding example 1, load shedding example 2. It also has created a service. Let's see if it is the case. So I'm doing a watch. So I'm doing a watch on the pod. I can see that two deployments are running. So deployment example 1 and example 2, both are in the running state. There is also a ready column, right? The ready column shows that if the application is ready or not. And this is where we have configured the readiness probe. The readiness probe is basically the health check endpoint. Every 2 seconds it's checking, right? It waits for like 2 seconds and then it checks if the actuator health is up or not. If the application is up, it will be showing us if it is up, right? So right now I think it is booting up. You can see that both the applications are up, right? Both are running now, so which is good for us, right? I have put a watch here -w. That way, if something changes in this deployment, right, we will be able to see that here if there is a state change or anything, right? Now let's go and look at the service. I'll go and look at the service, right? svc get svc. So it shows what is the IP address. I have the same IP address configured here in the loop.sh script. So what I'm doing is I'm doing a localhost curl, right? Instead of doing a local host where I'll run my application, I'm going to call the service load balancer within Kubernetes, right, which is configured to route traffic to these two instances, right? So this is the external endpoint, and also it's mapped to 8080. So that's what I'm doing here. I'm doing a loop on the external IP 8080 and greetings. So greetings is the endpoint which we have in the greetings controller here, right? So that's what is going to happen. So let's loop through, or let's first do a curl, right? I mean, just to check what's happening. So I'll do a curl. If you see here, this is not responding. That means this has hit our the pod which has the 90-second delay. I'll do one more curl. See here, we got a hello YouTube. So what load balancer does is it does a round robin, so it just transfers traffic to one instance to the other. So what happened, this instance is like taking 90 seconds, so that is stuck, right? However, there was another healthy instance, it was just returning me successfully. So see here, I mean, I'm able to get so this also got stuck. Now what I'm going to do, I'm going to run the loop.sh, that way we don't have to do the curl again and again. So loop.sh is going to call our curl endpoint and it's going to get the response code. This is because using load shedding we are returning a 503, right? If let's say more traffic is hit, that's why I want to do a print on the response code. Now if you see here, 3 instances are already stuck. If I do the third one now, right, I mean, if I do a loop here, this should not, or if I do a curl, right, this should work out still, right? See here, it is still working out. And also notice here, this particular pod, right, the example one is now not ready at all. Ready went into like 0, right? This is because the readiness probe failed, right? The readiness probe which we configured here, the actuator endpoint, that is returning a different response code. That's why this went off, right? And you see here, like, there's no issue with our site, right? I mean, we are able to like seamlessly call our server. So I'll show that by running the loop.sh, because that's going to be like running everything like indefinitely. So I'll show you. See, this is loop.sh, this is loop.sh. It's still waiting. I'll also run the loop.sh here so that you can see. So you see here, the new traffic is now redirecting and getting 200. So you see this scroll bar, that means it's just like returning only 200s, right? Now if you see, the application was running and then it went out of scope. And also again, now if you see, this particular script is now stuck, right? Because my loop is like stuck. However, if you see, the application went out of readiness, again it is coming back into readiness. That's because I did again a call. Let's do a loop again here, that way I'll show you. So I am running the loop.sh in all the places, and you can see my application is always returning 200, right? That means my traffic is not getting interrupted, though there is a load shedding happening. So see here, the pod is not crashing, but the pod is not ready. So we are telling Kubernetes that I'm not ready using the actuator endpoint, right? How does the actuator endpoint know that it's not ready? Because we are using the in-flight request filter here, right, to filter out and then send a response code which is like 503, right? We are sending a service unavailable error. That's how Kubernetes knows that, okay, this particular service is not ready, so I'll not route traffic, right? And you see there, every request is like now 200 only, right? There's nothing bad here. So all the requests are getting 200, right? And this is all happening within like seconds, because my periodic check is just 2 seconds, right? I mean, if you see my check here in the deploy YAML here, I put a periodic check of 2 seconds, right? Let's change this to like 10 seconds, right? I'll change a initial delay of, let's say, 15 seconds, right? I'll try to change this for both the pods, right? I'll show you how is that different, right? I mean, here you see there is no downtime for the application, because one instance is still healthy, which is the example 2, and that is serving the traffic, and the other instance is like load shedding, so it's trying to safeguard. Now if you see here, you can still see that there are some cases where we are getting a 503. See, I mean, we are getting a 503 and then we are getting 200. So even with a 2-second delay, there is some case where we get still 503s, right? However, if I change this and reapply, right? Let's do a reapply, right? With the new configured actuator health point. Now both the pods are getting restarted because we changed the deployment configuration. So both are going to be like redeployed. So they both are getting restarted, right? Now let's wait for it to restart. So once restarted, you will be able to see the same scenarios, because we have the loop.sh scripts running all over. So they are hitting our endpoints like crazily, and we will see that 503s often, right? Because those are going to be like coming in often. So see here, I mean, I can see the 503s very often, right? Let's wait also for the application 2 to come up, because that's the successful one which has 200. But meanwhile, you can see this, right? I mean, you can see that 503s are like crazily popping up. See, now the application is ready. Example 1 is ready. That's why you see 200s. right? However, again application went down, so it's again started returning 503. So see here, it's just returning 503. It's also a mixture of 200 and 503 because some of the calls are getting routed to the example 2, right? That's how it's getting that. The reason why we were getting 503 is because we were getting the load shedding. So the example 1 was load shedding, right? And also once it returned 503, the traffic is going to go to the other instance, right? That's why you see 503s and 200s. Also, the load balancer does a recheck only after 15 seconds, right? We have configured that, we have done a 10-second and then 10 plus 15, I think it has an initial delay as well. So I think almost 20 seconds it takes. That's why it's stuck in 503 for a long time, right? That's what happened here, right? That's why you see the application was like not responding as is. So meanwhile, the deployment got terminated and then they are recreated because what happened is there is a predefined set of number of readiness probe tries, right? That's why it was like stopping, restarting, but then it gave up at one point in time, right? That's what happened here. That's why it is terminating and then recreating the application, right? That's what happened in this case here. So meanwhile, what we can do, we can refresh these from the scratch. I'll do a delete and then let's reapply so that I'll show you the delay, right? Let's do a delete. So it has deleted everything. I'll do a reapply so that way everything is going to get created. So all these are going to run. Let me stop all the loop.sh scripts, right? And then we will start them once both are running, right? Let's do a clear. Yeah, they both are still there. Let's wait for them. So now both the applications are running. Let's do the loop.sh. We'll do a loop. So see here, you can see obviously that there are 503s, right? And these 503s are staying there forever, right? I mean, that's because we have a 10-second keep alive timeout, right? That's what the readiness probe delay is, right? These periods are basically for every 10 seconds is when the health check is going to be running, right? So Kubernetes will do a health check only after 10 seconds. So for that 10 seconds, I'm going to get unhealthy responses for my request, right? That's what is happening here. So see here, now if you see after the 10 seconds, this particular application is now out of the load balancer. So see here, it's 0 1. That basically means traffic is not getting routed here. And I see that all are 200. So see here, all these are like the requests are going through. All these are like returning 200 now, right? So I don't see any issue here, right? So every request is like succeeding. All these are like new requests, right? These are like continuously returning new request. All these are successful. Now once this example 1 comes back into play, right, then what will happen is it will again have the 3 threshold limit, and then after the 3 subsequent calls, again the application will be like going through the 503 errors, right? So you can see that. Let's wait for a few more minutes and we can see that right now again the 10-second delay is going to kick in. So that's why we are enjoying the successful responses here, right? So let this application come back into the readiness state and then we'll see what happens. So see here, all these are now successful. All my requests are getting succeeded. See here, now the application got succeeded for the readiness, and I can see that the threshold is reached, and you see 503s are like popping in crazily. It's like now this guy is like stuck again, and then here also is 503. So again, until we have the next 10-second kick in, and then health check realizes, okay, this is returning 503, I'm not ready, it will just go out of the readiness. So see here, it's gone out of the readiness, and I can see that all these are returning 200. Here I think the load balancer is still routing traffic, or maybe my logs are like, yeah, I think the latest ones are good. So see here, all these are 200 now. All the new requests are all 200, which is good news. So this is how you can leverage load shedding in Kubernetes. If you see the power of Kubernetes platform shows up in the way we are using load balancers, which are nothing but servers, right? So using servers, I routed traffic to 2 different instances. One was healthy, one was not healthy. In the sense, one was doing a load shedding even for 3 instances. The other was like returning responses quickly, right? And using readiness probes with health check endpoint, you are able to easily route traffic to the instance which is healthy, right? So this is how you can leverage load shedding in Kubernetes. Do try it out in your space if you're using Kubernetes. If you have an application which needs load shedding or rate limiting, do try the examples which I have shown. It's definitely beneficial, and do let me know the feedback, how it went, or how did you like this video. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.